Last week when I dismantled the Samsung laser printer, I was able to recover a couple of these motors and motor controllers. I originally thought they were stepper motors, but they're actually three-phase brushless motors, and they've got completely kind of control circuitry all mounted on this PCB here. I just had a little play with these this evening and I managed to get it up and running. The motor itself, I believe this is the full motor unit model number rather than the actual motor attached to it, is a JC31-00021A. Now if you do a search for that, this part does seem to be available. A lot of kind of spare parts are out there. And it uses their kind of a motor controller driver chip on here, and it's an LB11923. And obviously that then kind of returns a datasheet with the full details. So I was able to identify how this operated. The labelling on the front is good, but it's not perfect, and it is a little bit confusing, some of the labelling, unless you know exactly what it means. So I'm just going to run through the circuits I kind of set up for this to test them. So this is the circuit I'm using. This is the connector from the motor, plugs into it, and I'm just feeding off all these pins into the breadboard down here. The motor requires a 24 volt supply and a 5 volt supply. So what I'm doing is feeding in 24 volts from the bench power supply, and that's coming in and being fed directly into the motor terminals, which terminate there, and then using this just little 5 volt regulator here to produce the 5 volt rails, and they're then fed down into the 5 volt terminal for the motor, as well as these two bottom rails here. The motor itself I'm just going to hook up now. But that it kind of responded straight away, but it was a little peculiar, and so I had to start tracing through the datasheet lines just to find out what their labelling meant. Because I'll zoom in there. These are the labels they included. The ones at the bottom are the most interesting. The start, ready, clock, counterclockwise, clockwise. The clockwise, counterclockwise option wasn't in place. You can see there's a missing pin in the kind of cable. But the start, ready and clock, I assumed they were kind of data lines, certainly the start and the ready to trigger things, and then clock, presumably a speed signal. And but so when I tried this, I got some slightly bizarre results. I'm just going to zoom back out and replicate that now. Disconnect that line. I power up the motor. As it spins slightly on first load. I don't know if that occurred every time, but then nothing. The only time I could get it to really move was by toggling this first line here, which is the start signal, and by kind of toggling that, it would spin up. And so if you repeatedly toggle the start line, you can almost get it up to speed, which is a little bizarre. The other thing that it wasn't obvious from the labelling, which I found out, the ready signal is actually an output. This is a signal which the motor outputs to say, yes, I'm now running at speed. And so I fed this signal to the LED down here, the board. The output line goes low, so I'm just feeding this through a current limiting resistor to the positive line. And so if it's ready at speed, that will turn on. I don't have a signal generator, so what I'm doing for the kind of clock signal is a little trinket here. I configured this to toggle between two output frequencies. I think 16 kHz, which was listed as the maximum frequency for the clock input, and down to 2 kHz just as in contrast, and the red flashing light represents switching between the two frequencies. The red is the lower of the two frequencies. So if I connect the clock signal back up to that input, you can see nothing happens. This is a protection feature built into the system, so if it detects clock anomalies, it shuts down the motor, it basically turns it off, and so you then need to kind of toggle the start line. Oh, sorry. Okay. You toggle the start line and it starts running. See, the light back here is illuminating to indicate that it's ready. If I move the light out of the way, you can see how this changes. Whenever this changes, it takes a moment for the motor to get up to speed. So now the light's gone off as it slows down, and then eventually this light toggles back on when it's slowed down enough to be at the desired speed. Speeding up, it's much faster to get up to speed. You can see as soon as this light turns off, it almost immediately reaches speed. There's very little delay at all. If I apply some manual load to this, you can see it flickers there, but also it means when it turns into the lower speed mode, it's much quicker to get there. As you expect, I guess. So there's a fair bit of mass there that has to slow down, and it doesn't seem to do any kind of obvious braking to do that. There is some kind of braking functionality, but that isn't broken out into this header. The motor itself, I haven't tried loading it too much because it's knocking out the power supply. If I go into the power supply there, you can see the current draw is pretty low, a couple hundred milliamps when running at normal speed, and then you get the odd spike when it switches. If I load this up a little bit, obviously the current increases, but if I load it up too much, it reaches the limit for the power supply and the whole thing kind of reboots. And in this case it rebooted so much that I need to toggle the start line again to get it back up and running. So that is that, and obviously the start can then be brought back to positive line, and then that brings it to a stop. So it's an interesting, nice little motor. It does have this twisted screw kind of thread on there, which is not so useful, but I did save a number of the cogs that came out of this, so it's possible I can match this up to something. But yeah, the other thing would be to possibly look at the some kind of speed output setting, or find out the exact calculations for the input frequency versus the desired speed. But again, I think it's certainly a useful part. I mean, it is quite fast. Again, I've got no real idea as to how much load it can take before it cuts out, or how much current it would require to load that. But I could certainly see this being useful for some applications. So there it is, the motor out of the Samsung laser printer. And so I've got two of these.